Everyone remembers the question, right? You're supposed to choose 12 committee members. Let's write this on top maybe. Choose a committee with 12 members out of 10 men and 10 women. With these restrictions. The first one has no restriction, but the other ones have restrictions. You can solve it there. It's okay. I just wanted to write it again. So the first one is easy. You have 20, total of 20 people available, no restrictions. You're choosing 12 members. So it should be 12 choose 20. That's exactly the formula. The second one, they have 6 men, 6 women. So they have their own pools to choose from, 10 women to choose from, 10 men to choose from. So you choose the man, and then you choose the woman. You multiply because this choices is 2-step system. Like it's an experiment with 2 steps, right? Now C, we have restriction of choosing even number of women. So all possibilities that you can have even number of women. You cannot have 0 women because then you wouldn't have enough people to choose from. So the lowest number is 2. You can have 2 women. You can have 4 women, 6 women, 8 women, or 10 women. And then if you have those restrictions, you will have 10 choose 2 times 10 choose 10, and so on. And you have to add these because these are cases that are independent from each other. Okay, for those of you who are looking at their iPads, I need attention here. Ask questions if you need to, but make sure you understand this. So there must be more women than men, which means total 12 can be separated as 7, 5, 8, 4, 9, 3, 10, 2. And there's no other possibility, right? More women exclude the equality because equal means not more. Right? Now number E, there must be at least 8 men. So you say, okay, it can be 8, 9, or 10. That's all you get. One last question before you leave. Is this the even one that you calculated? Is it exactly half of the choices you make in A? Because there can be even number of women or odd number of women. Are they equal? Exactly half?
Huh? I think they are not equal.
They are not equal.
Actually, I taught this yesterday, but I forgot why.
Is anybody calculated during the homework if the answer in C is exactly half of A or not?
It's 6, and both of them are 6. This is also even.
The middle part you may.
And the remaining parts are equal.
Because it's a product of 2 permutations, it feels unlikely that it's actually exactly equal. But if somebody has one of these machines, if you calculate the A and you calculate the C, do you find it exactly half? Can you calculate? Calculate A, what's the number for A, and then calculate C and see if it is exactly half. How many people think it's half? How many people thinks it's not half? You understand the question though, right? This is something that one of your friends who just told me now, when he's living, he said, because the even is same as odd, so it should be exact half of it should be even. And I said, no, there's no reason. But if it is half, we will know. Thank you. So with your calculation, you can check if the exact half of it is that way. Did you calculate? This one is 100. 500. 970. Okay, so what's this one? This looks very big to me. Is that right? So everyone knows what this is? It's 20 times 19 times 18 times 17 times 16. You can take this as 20 choose 8, right? So you just need to go 8 numbers. And then divide by 8 factorial. And then you can do a bunch of cancellations to simplify it. So 13 times 17 times 19 times 30. Is this number? Okay, this one looks much smaller to me, honestly. But there's things like this, maybe it is. So what's this number? The subplane? Somebody can do it at hand too, right? It's not that hard. Like 10 choose 2. What's 10 choose 2? 45. The 10 choose 10 is 1. So there's nothing. 10 choose 4, 10 choose 8. Those are big numbers. Ten choose 6 is the same as 10 choose 4. You can actually do this. And it's symmetric, so you get twice as this. It's, no way it's close to that, but. So this is the number you're supposed to add up. Can you add this up? 45, 210 times 45, 210 square. Actually, this is same as this, not twice. And then 45. So it's actually 2 times 45, 2 times this, plus 210 square. Let me open a discussion very similar to this until this is with products of certain things, right? So suppose you're not doing products, you're just choosing, say out of 10 people, you're choosing, what's the number? Huh? So what's the number? Huh? 63,000. 90. So what's the twice of that? Is this number? 63,090. It's close, but. It's close, but something is missing. What's the missing part? So it's not a half. Okay, think about it. I will ask you something much simpler. Suppose you have 10 people, okay? And you're choosing some members. And you want this, so out of 10 people, okay? Out of 10 people, or 10 students, we want to choose a committee. With even number of members. In how many ways we can do this? This is similar to that question, but instead of man and woman, you just have straight 10 people, you're choosing members. So what's the answer? We just saw the question like this, right? So what's the answer? The answer is you choose 0 members, which we can do one way. 2 members. You can choose 4 members. You can choose 6 members, 8 or 10. Okay? So 1, you get 10 choose 6, 10 choose 8, 10. So it's exactly the same numbers on this side. And this one. So if I ask the same question with odd, what will be the answer? If you want to choose...
Hocam yılında sıfırını niye katıyoruz ki? Hem çift komite seçmek istiyoruz hem seçmek istemiyoruz.
So even means a number that's divisible by 2. So because of that general definition, 0 is an even number. And for choosing a committee, a way of choosing a committee with no members is a way. So we have to include it.
Niye komite seçmek
I mean, if you start not including choosing 0 members, it causes problem with choosing 10 members. Remember, like when I say I want to choose 10 members, I said this is exactly like if you want to choose. This was the formula. Remember, with I people out of n, I said this is same as choosing n minus I people, choosing the members who's not going to be in the committee, right? So instead of choosing people who's going to be in the committee, we said it's the exact same as people who's not going to be in the committee. So if you allow 10 people to be chosen, you should allow 0 people to be not chosen. So 10 choose 0 is necessary because you want to talk about n choose n's. Okay? They're like pairs with each other. If you start excluding this possibility of choosing no members, then you start excluding choosing all of them as committee. Okay? It's not like a choice. You basically say, everyone, you will be in the committee. But that's saying 0 people will be non-chosen, right? So you have to allow 0 to make this stable. Otherwise, you get nothing here, you know. That causes a problem. So you have to allow that. Okay, so for odd, what's the answer? Anybody knows? So it's 10 choose 1, right? 10 choose 1. I mean, from here, I want to get to somewhere about this pairness. Okay, these turn out to be big numbers to calculate, but if somebody calculates, you will see that these are actually equal. Let's do a small calculation just to. If I had, instead of 10, if I had 7, I will be having 7, 0, 7, 2, 7, 4, 7, 6, right? So these are the even ones. These are the odd ones. 7, 1, 7, 3, 7, 5, 7, 7. So these are the similar problem with 7s. And I also claim that these are equal. Which you can actually check. This is 1. Let's calculate it. This is 35. This is 3, 21. So 56, 8 more, 64. And if you calculate this, you get 7 plus it's actually, you can see the same numbers you're calculating, so you get 64. So here it seems like summing up the odd ones and even ones are equal. So can we make a claim for any n? If you sum just the even ones, this is a notation for even ones, where you start from 0 to the biggest integer you can find close to n over 2. Is it possible that it is same as these ones? You can actually start with 0. If I claim such a statement, what's the chance that it's true? Huh? Say it again? Huh? It's the integer, like if n is even, you are saying we are passing the, it's 0 anyway, so we don't care. But if it is odd, then we need this. Okay? There is no problem with going to a bigger number because then you get 0. If the bottom part is bigger, you declare it to be 0. Okay? So can you tell me why this is true? If it is true. Is there a logical reason? Let's draw the Pascal triangle and analyze this a little bit. So what we just said is that for n choose i's, if you look at only the even ones, you get same as the odd ones. So for example, for n equals 3, if you, this is 0th one, this is the second one, and it's equal to this one plus this one. It makes sense, right? This plus this equal to this plus this because they are summing the same things. You can look at what we had with 7. These numbers we had was 1, 21, 35, 7. And the numbers I had here is again 7, 35, 21, and 1. They cancel each other, right?
When we perform the selection, we can write the steps of product group. For example, when we indicate the number that we select among the group. For example, we can choose even or odd. Then the other step, choosing the persons. Then ordering maybe. We can proceed this way. Then the even or odd step can be divided.
So you're saying they're equal because they're symmetry? What is it in terms of... So here you see that these numbers are equal. So because of that, if you sum the circles and if you sum the blocks, they cancel each other. They're equal. Right? Is this a valid argument for all n? Is this true? Huh?
The number of even selections and odd selections are equal.
Is this the reason?
No, it's only the odd case.
Yeah. See, don't be tempted to say, oh, I see a pairing, so it should be true for all n. Just look at the next here on this row. Summing the evens here is actually summing 1, 15, 15, and 1. So you actually summing same numbers twice. But miraculously, it becomes still same as this sum. So they're not pairing, but they still are, both of them equal to 32. So why then they're equal? I mean, here they're equal because you can pair them. So when you choose, say, one member, here is same as choosing 6 members. Here you choose 2 members, it's same as choosing 5 members. So choosing even number of members is same as choosing odd number of members because you have total odd number of people. So they're complement to each other. But if you have total even number of people, like 6, your odd numbers and even numbers are not nature repaired with each other. So why we still have equality?
Maybe we can go one step back and look at the fifth row,
Uh-huh.
the summation.
So it's here you say they cancel. Here they will cancel too.
Because we add the row and proceed.
So you're saying 15 comes from 5 and 10. This 15 comes from these. This one is this. This one is this. So these numbers are exactly equal to the sum of the previous row. Can you show it for general n?
I think it's easy to see it this way. For example, for the fifth row, any number goes to the, for example, 5, second 5 numbers.
Uh-huh.
Go to the 6 and 15.
Uh-huh.
So it goes to the neighbors numbers.
Mhm.
One of them must be odd, and the next one must be even.
It's same argument. It's actually a good argument. I mean, they're both correct. That you can think the numbers are some of the numbers from the upper row. So if you only look at the even ones, you will be counting every number above this row once. Okay? Because you're not counting these anymore. So that means you're only counting these ones above that. In the same way, if you count these ones, say 6 will be coming from 1 and 5, 20, 10 and 10, 6, 5 and 1, you again count exactly equal to the previous row. So we are actually equal because they're both equal to this sum, you can say. And it's a valid argument. But still it will be tiring to write this as a proof, right? To say it for all n. Is there another way?
For example, write 7 choose 2
Yeah. I mean, it's the same argument. How about I do this? Okay, so I will do this. I accept that these are correct answers, okay? Just give you another way, okay? So this is one way to answer this. So think about the numbers on the left, these even ones. We want to show that they're equal to the odd ones, right? The odd ones, put them on the left-hand side and write minus in front of them. So you get plus minus, whatever the nth one is. It could be plus or minus. You want to show that equals to 0. So if I write in terms of this one, for example, what I'm saying, it will be minus 6 plus 15, minus 20 plus 15, minus 6 plus 1. So you need to show this is 0. Okay? Now, I'll do a very, very, very simple trick. Remember the binomial theorem? It said 1 plus x to the power n is same as such a sum with x to the n and y to the n minus I. So I'm saying that this sum is 1 plus minus 1 to the power n by binomial theorem. Just look at the theorem. I can write it again if you want. Let's write it here so you see it. Just to remind you what the binomial theorem is, this is an application of binomial theorem. So it said this was the binomial theorem. It said that if you take x plus y to the power n, where n is integer, and this is true for any x and y, you get x to the n plus, this is actually n choose 0, but we don't, n choose 1, x to the n. So the general term looks like this. So there is no x and y to that. So put x equals 1 and y equals minus 1. So you get 1 times n choose 0, 1 times minus 1. N choose 1. So you get minus n choose 1. N choose 2, 1 times minus 1 square, which means plus 1. So you get n choose 2 with a plus sign. So you get exactly plus minus plus minus. The general term here with these things will look like this. The last term is actually, as I wrote, looks like this. So this sum that we want to show 0 is equal to this. But you can see that 1 plus minus 1 is 0. 0 to the n is 0. So that's why it's 0. So it's basically an application of binomial theorem to say that these numbers are equal to those numbers. Okay? Very simple argument, but before the break, also, I should mention that if we take, this is also something you should know, if we take x equals to 1 and y equals to 1, then what we get is the same formula. This time it's the sum of all the rows. Okay? So sum of the rows. And I mentioned this last time. The sum of the rows they are like 2 to the powers, right? So here you get 4, here you get 8, you get 16. So these are 2 to the these numbers. 2 to the 3, 2 to the 2, 2 to the 4. So in general, the sum of the numbers on the nth row is equal to 2 to the n. And you can see why it's true, because you put 1 here and 1 here. So you get 2 to the n. That's why it's true. One time, I mean, you can make many choices here, right? So you can do 1 and 2. So you could be asked n0, 2 to the n, 2 to the n minus 1. What's that sum? And the answer will be 3 to the n. Some very non-trivial summations you can obtain by playing with the binomial theorem. So whenever you have a sum which involves these n choose i's, together with some powers, always think about binomial theorem. Okay? Try to see if you can obtain it from there. Any questions? Okay, let's take a break. I have some quizzes back from the second quiz. If you want to look at them, it's in the front. These are your second quizzes graded.